addition and subtraction of fractions. In this video, I want to be able to show you how to solve the following three examples. Now, before we get into the examples, so here's the little short agenda, what I will go over. So I want to be able to do basics of addition and subtraction, and that brings in the concept of like fractions, having a common denominator before you start adding or subtracting. Then I want to take the examples that I just showed you and provide to you some kind of a systematic way of finding the lowest common denominator. Now, if you like, because you're going to need to understand prime numbers and prime factorization, you can watch the following video on primes, which is one of the videos that I have created. Now, other videos in this series will be adding and subtracting mixed numbers, and you're going to be able to watch that. And then finally, expressions of fractions and mixed numbers, where multiplication, division, addition, and subtraction are all combined into one. So let's come back to this agenda. So adding and subtracting basics and understanding like fractions. So the basics of fractions are with the concept of simply being able to add and subtract any integers. For instance, if I gave you -3 plus 5, and you try to solve this, your answer will be +2. Now, with fractions, we can do exactly the same thing. The only difference is that fractions have a numerator and a denominator. So if the -3 and 5 were your numerators, and I created a denominator of 7, as long as your denominators are the same, it doesn't change anything for us. The answer is still 2, and the denominator stays the same. So that is the basic of adding and subtracting fractions. As long as your denominator stays the same, then all you worry about is what happens to the numerators. Now, having a common denominator like we have it in this case, this is known as like fractions. So they're alike because they have the same denominator. Now we want to be able to take any example, and if they do not have common denominators, what we want to do is we want to be able to find a common denominator between them. And ideally, we want to find the smallest one to make our life easier, so we don't have to reduce down the line. So let's come back to the examples that I gave you originally, which were these three. So I'm going to copy these examples, and we're going to tackle them right here. The first example, which you see, doesn't have a common denominator. Neither does the second or the third. So what do we do in order to find a common denominator? Now, if you had some fraction experience, a lot of people will just start guessing, and they might actually see that a common denominator between these two maybe is 24, and that's indeed the case. However, you don't always get to see it right away. If you do, great, but it would be nice to know some kind of a systematic way of being able to find the lowest common denominator, the smallest denominator that both of these go into. So here is a systematic way for the first example to find your lowest common denominator. So for instance, what I do is I create a table. Now you don't have to create a table, you can do this as you please. And then I just simply use prime numbers to try to prime factorize both of these simultaneously. So the first step is I will take, ideally, in my case, what I do is I take the smaller one, and then I simply try to see, okay, what is a prime number that goes into 8? and then I know that it is 2, and 2 goes into 8 4 times. And then I check if this prime also goes into 12, and it does. And it goes in 6 times. So I have now prime factorized this 8 and 12 by 2. And I continue this process. So I still notice that 4 is divisible by 2 once again, and it will reduce this to 2. And, well, as luck has it, 2 also goes into 6 3 times. And now, next, okay, what I want to do is I want to see, okay, well, 2 is already a prime, so it's definitely divisible by 2. So that will go in 1 time. However, 2 does not go into 3. So what happens in this case when you run into a prime that doesn't go into the second denominator, or maybe the third? What you do is you just simply leave that denominator as is because you cannot reduce it by that prime. And once you find yourself reaching the bottom, meaning that you've reached a 1 in a column, you stop because clearly you can't reduce 1 any further. So I will now come back to the other column with the 3, and I know that 3 is prime, and it's clearly divisible by itself. And notice now I have reached a 1 in both columns. Once you reach a 1 in both columns, then the primes on the left-hand side in the table actually tell you that you have prime factorized both of your denominators. You've reduced them as low as you possibly could. So what does this left-hand side give me? All of these primes. Well, it turns out when you multiply all of them, they actually provide you the lowest common denominator, and that is 24. Now again, you could have guessed that maybe right in the beginning, so you wouldn't have to necessarily do this step. However, okay, remember that you may not always be this lucky to see it right away. So it's nice to have a system, and this table just simply shows you if you're not sure how or what the lowest common denominator is, this process tells you how to do it in a systematic way. And I'm going to repeat this for the other examples so that you slowly see what this process is. And hopefully as you're seeing the other two examples, you'll understand what to do with the primes. So let's finish this example because we want to be able to do this addition. So we have identified that in our example here, we have a lowest common denominator of 24. What does that mean for us? Well, remember that in order to add or subtract, we have to have the same denominators, and we do not. So finding this number, this 24, just simply tells us that we can transform our two fractions into 24. So once you have that lowest common denominator, what you do is you take 24 and first you divide it by 8. And that just gives you a multiplier, meaning 8 times 3 gives you 24. And I need that because if I changed 8 to 24, I have to change the negative 3 as well. And I have to multiply it by the same multiplier, which is 3. So that's going to give me negative 9. And now for the 12, of course, it's going to be different multiplier. So 12 goes into 24 2 times. And now you're going to take the 7 and also multiply it by 2 times. And that will give you 14. Now we have the same denominators. And once you have the same denominators, well, we can now go ahead and simply say negative 9 plus 14. And that is equal to 5. And the denominator just simply stays the same because we have like fractions. I can't reduce this fraction because 5 doesn't go into 24. So that turns out to be my answer. That's question number 1. Now let's take a look at question number 2. So this one is more complicated because it has 3 fractions. So what do we do in that case? Well, we do exactly the same thing. We want to find the lowest common denominator. And for that, if you can't see it right away, then remember, just simply take all your denominators, write them side by side, and now let's try to find a systematic way of finding the lowest common denominator. And that is using primes. So what I do again is I take the smallest denominator, in this case the 6, and then I ask, well, what is a prime that goes into 6? And I know that it's 2. So 2 into 6 goes 3 times. And now I also check if this prime will go into 10 and into 18. If it does, then I reduce. If it doesn't, then those numbers stay the same. In this case, 2 goes into 10 5 times, and 2 goes also into 18 9 times. So that's my first reduction. And now I continue. Remember that in a column, I want to get to reduced form where I only see a 1. So now I see a 3. Well, 3 is prime, so it's only divisible by 3. And that's going to reduce the 3 for me into a 1. Now 3 doesn't go into 5, and this is what I mean. When this happens, then you just simply rewrite the number. Nothing changes. And then I'm going to check if 3 goes into 9, and it does. It goes in 3 times. So now I have reduced this by 2 and by 3. I am done with my first column because I see a 1. So I move over now next to the second column where I see a 5. 5 is prime, so I can clearly reduce by 5. And that's going to drop this to a 1. 5 doesn't go into 3, so remember that this will just simply stay the same. And now I have 2 columns with a 1. So I have reduced 2 of these denominators. And then the final one, which is the 3, so I can clearly divide this by 3, and it's going to give me a 1. So now I see 1s in all 3 columns, and that's when I stop. And that tells me that these primes on the left-hand side, when I multiply them, they will give me the lowest common denominator. So 2 times 3 is 6. 6 times 5 is 30. And 30 times 3 is 90. Now, if you looked at the original question, I don't know, maybe you're very good and you can see that the lowest common denominator was 90. I probably wouldn't be able to do that right off the top of my head. And this method just simply shows me how to do it systematically, so I'm not guessing. Now that we know our denominator, we can break this down. So here we go. We'll put the denominator as 90 for all 3 of the fractions. And so now we're going to take a look. So 6 goes into 90, and we can check. So how many times it goes. So it goes actually 15 times. So we're going to multiply this by 15. Okay, so now 7 times 15 is 105. And you can do that on the side for yourself if you like. Now the second one, so 10 goes into 90 9 times. 9 times 7 is 63. And finally, we have 18 goes into 90. So this will be a little bit of thinking. So we have 90, so this is, so it's 36, 72. So that goes 5 times. And you can check for yourself. So we have this is 40, 90. So indeed, 5 times. 5 times 11. And that gives us 55. So now I can go ahead. So I have 105 minus 63. So I am just subtracting these from left to right. So if I do the subtraction, So this is 2, and this is 4. So I have now next plus 55. Can do that. That will be 7 and 9. So we have 97 over 90. And so finally, so we can change this back into a mixed number. So this would be 1 because 90 goes into 97 once, and then we have 7 over 90 left over. Now you can check if 7 goes into 90 in case there was any reduction. So we can do that. 7 into 9 once. And notice we'll get that. 7 it goes into 22 times, but it will give us a remainder. So this is actually our final answer right there. All right, that completes this one. So in the third example, which is this one, let's proceed with exactly the same steps. So I have 3, 15, and 6. Well, that's not going to work. So let's try to see if I can find the lowest common denominator by using the method of primes. So what is a prime that goes into 3? Obviously, it's 3. So that reduces the 3 right away. Now, does 3 go into 15? It does. It goes 5 times. Does 3 go into 6? It does 2 times. So I am done with the first column, and I can now move over to the second column, which has the 5. Well, 5 is divisible by 5. So that will give me 1, but clearly 5 doesn't go into 2. So remember, if it doesn't go, you just keep it as it is. So that is 2. So now I am done my second column. And then my third column, so well, 2 is prime and it's divisible by 2. So that reduces the last column, which means that the multiplication of these, so 3 times 5, which is 15 times 2, which is 30, is my lowest common denominator. So I will now change these so all fractions will have the same denominator. And now I can check with this. So I have 3 goes into 30. That goes in 10 times. So 11 times 10 is 110. 15 goes into 30 2 times. So 1 times 2 is 2. And 3 goes into 30 5 times. 5 times 5 is 25. And now I can go ahead and do my additions and subtractions because I have like fractions. So 110 plus 2 is 112 minus 25. So we can do that here on the side. So 2 minus 5, I'll take away from here. It's going to be 12. So 12 minus 5 is 7. So 0 minus 2 again I can't do, so I have to say 10, okay, because I will borrow the 1 from here. So 10 minus 2, so that becomes 87. And of course, don't forget that you have it over 30. So this is an improper fraction. So if you like, you can change it to a mixed number. So 30 goes into 87 2 times. So that will be 2 times 30 is 60. And then you have 27 over 30 left over. And you can check for yourself because I mentioned in the agenda that you can watch one of the videos, and that is on proper, improper, and mixed numbers if you want to know how to change back and forth between improper and a mixed number. So that's the answer to this third example. So again, the key is you need to have a lowest common denominator in between, and I showed you 3 examples on how to do that systematically without guessing. You can guess if you're good, but if you cannot guess a denominator, then try to use this method. Okay, thank you for watching.